Hello everyone. In this video, I would like to talk about absolute beginner in Docker and want to learn about it. This is the right video for you. So in this video, I will discuss about the different features of Docker and how it can be helpful to you. To start with, I would like to tell why do we need Docker. So just before cloud was introduced in the ecosystem of technology world, uh, we had to run our applications in the VMs. But once the cloud was introduced, we could run our application as IaaS or PaaS, like infrastructure as a service or platform as a service. So what is infrastructure as a service? In infrastructure as a service, cloud providers provide us the infrastructure to run our applications. Basically, these could be the VMs provided by the cloud providers, where we can install our applications and run the applications. So these VMs would be of very would be there in the ecosystem of the cloud provider, and or what we say as platform as a service, where all the services would be provided by the cloud provider like SQL Server, serverless functions. But the problem with the platform as a service is that it is highly coupled to the cloud, and it uh, it makes it makes uh, it difficult for the developer to move the applications across the cloud. And the problem with the infrastructure as a service is it proves to be very costly for the organizations which are using these services. So Docker came up with a third option to move each of the components to individual containers. And with that, we got a new term known as microservices. So microservices are the components which are installed on individual containers. So many people confuse microservice term with the individual services installed on the web servers, which I have noticed, but that is not right. So if you have multiple services running on, suppose IIS, multiple basically web services running on IIS, that is not a microservice. So microservice is the term which was originally coined once the Docker was introduced. So Docker helps you to get existing apps to the cloud, whether they are distributed apps or monoliths. So this is uh, why Docker was introduced. In the next slide, you can see the two models which I have already discussed. That is as is infrastructure as a service model, where every component run on its own VM for isolation. So basically, this is an easier migration, but uh, there are chances that VMs which we are using, they must be underutilized and they are expensive to run. So basically, each VM would be running each component of the application. And the other diagram, you can see how we are using platform as a service model. So each component gets mapped to a managed service from the cloud provider. Like we have individual services which are provided by the cloud provider, like SQL Server, Azure Functions, or mailing service. So all these services are provided by the cloud provider, so that we can use them. But as I mentioned, the problem with this kind of model is that our application would remain highly bind it to the cloud provider, and it would not be easy to migrate to some other cloud provider if you want to do so. So this is the container model where all the application components are basically run in individual containers. So basically they are isolated like VMs, but lightweight and efficient like platform as a service model. So Dockerized applications are portable. They can run in a managed service like Azure Kubernetes, and they can move to AWS or even to individual data center with no changes. So what is a Docker? So Docker is a platform that lets you package, develop, and run applications in containers. So basically, you can have your individual components of applications, and you can package those components and bind it to individual components and run those individual components separately across in the containers in on same hardware. Basically, it would be same VM or your data center server where all these components will be running, but they would be separated by the boundary of containers. So container is a virtual environment on top of OS kernel to capture all its software, libraries, dependencies, etc. So one interesting thing about containers is that though the applications would be running in container, but the processes would still be using the memory of the VM on which the this container is running. It means that if you open the processes on the VM, you could clearly see all the processes which are originally running on the container. So it's basically the processes are running on the container, but they would be using the OS or kernel of the VM on which the container is running. So containers share the CPU and memory of computer as well as computer's OS. So containers basically don't have their own CPU and memory as well as OS, unlike VM, where VM would be having its own CPU, memory as well as OS. That's why it makes a costly affair to run the VM on a computer. So this solves the problems of isolation and density. So it's not mandatory basically to run or to have the required softwares to run our application on the VM. Basically, if suppose if my application uses IaaS and SQL Server, it is not mandatory to have IaaS and SQL Server installed on my server. I can just directly use the image which already has IaaS and SQL, and I can download that image on my server and use the container and use it as a container. So it will basically keep my VM clean, and anyone who is starting with the development just directly download the container from the Docker Hub, or it could be our individual hub as well. So it would be stored in the so the containers or images are basically stored in the hub, Docker Hub, where the creators of these images store them to be used by other individuals in the future. So, uh, so when it comes to Docker containers, the question arises. Everyone starts wondering if the VMs were already there, why containers were introduced. So it is very important to distinguish between VM and container. The original attempt to solve the problem of isolation and density was VM. So containers basically provide us solves the problem of isolation and density. Like we can run any number of containers uh, on a VM, but that would not be true with VM. It would basically be solving the problem of only isolation, not the density, as VM would be using its own CPU, memory, and OS. So memory consumption from the point of view of VM would be high. So VM is similar to container bit, but it has its own OS and kernel. It doesn't share the OS with host computer. Okay, and VM consumes a lots of memory as well as CPU to run its own OS, which is not true with container. And we have to maintain the licensing cost of OS. And containers share the OS of host computer, making it lightweight. Containers start quickly and run quickly. We can have 5 to 10 times containers on the same hardware as compared to VMs. So as you can see, the number of containers we can maintain on the same hardware. So the problem with VMs was that we had to manually run and stop the VMs, or uh, we need to write some script to do that. But that is not true with containers. Once the process which you want which runs in the container is stopped, or if it is done with its task, the container stop on its own, releasing the memory. So we can get the benefit of density as well as isolation, making the most efficient use of hardware. And the last point is the file system between each of containers is shared. Since the file system is shared, it would be used by all containers and wouldn't be re-downloaded. We can start any number of containers without overloading host machine spaces. Okay, so this is the way how containers are run. So each host computer has a separate computer name, IP address, and a disk. Containers all shared host, operating system, and memory. And coming to the VM, the host computer has a separate computer name, IP address, and disk. VM all shares host CPU as well as memory as well. So this was the difference between uh, containers and VM. So coming to Docker images. So this is a very important component while understanding about Docker. So Docker images are read-only templates with instruction for creating a Docker container. So instructions define the container code, libraries, environment variables, configuration files, and more. So these are basically layers of instructions which are stored in the Docker Hub. And these instructions are collected within the executable package. When we run this executable package, we create the container. Containers are result of executing these instructions. We can use analogy of object and class in OOP to define relationship between image and container. So images are basically a templates which are stored in Docker Hub mainly. And once we download these images and use for our purpose to solve to run any service, these images are turned into containers. So that was all about brief introduction about Docker. I would like to demo you a small Hello World application uh, within the Docker. Okay, so in this part of video I would like to show you how uh, we can run a container inside our VM. So this is a Windows server. On this Windows server, as usual, I would start with running the hello world container. So to run the container, so as you can see, the image for this hello world container already existed on my VM as I have downloaded it earlier before shooting this video. And once the image is once the Docker sees that image already exists, uh, it runs that image from that cache, and this is the output from that image, hello from Docker. And so if we want to go and see inside the image, so uh, if I want to run my command prompt inside the container itself, I can use this IT flag. So this is basically an interactive flag, and this command helps me to run the command prompt inside my container. So this last parameter is CMD. This shows that I want to run command parameter, command prompt inside my container. And once this is done, you can see that there is a new command prompt, and if I do the directory, you can see I'm present inside the command prompt of my container. So now since I am inside the container and I am inside the uh, file system of container, and as you have seen, these are the files present inside that container. If I want to see the contents of this text file, so as you can see, these are the contents which we saw while I ran the container from my VM. So this is how it works, and now I am coming out of that container, and currently now I am inside the VM, my own VM. And one more thing which I want to show is I can list down the containers which are there on my system. So currently there is no container which is running on my VM, but if I add this all switch, it would show me the containers which have been stored in my VM's cache memory. So as you can see, the command which executes while I run this container is command cmd. So this will helps this container to display the hello world message on the command prompt. So each container is basically associated have with its own command. So it could be starting of some service, display of some message, or starting of some script file inside the containers. So this is how containers work. And if I can see the images present on my VM. Okay, Docker image ls. So these are all the images which are present in my uh, VM. So this is the image which has been used to demo the hello world example of this container. So with that, I hope you have some basic understanding of Docker's containers and images and why do we use container instead of images. So if you like this video, please do like the video and subscribe for this channel for further updates. Thank you.